Okay, for this one, let's see if we need a free body diagram or not. They want angular velocity, angular acceleration of the gear, so it's not a dead giveaway. They're not asking for a force or a torque. So therefore you have to calculate the degree of freedom. Now they show us that this collar is moving. So if you hold that collar still, so there's at least 1 degree of freedom. If you hold the collar still, then nothing else can move, because this is, by the way, this is what's called the rack. It's like a gear that's straight, and they say that that's fixed. Well, if this rack is fixed, then the point right here in the gear teeth, those can't go anywhere unless the gear can move. So if this is stationary, and this is stationary, then then everything is locked up and nothing else can move. So there's 1 degree of freedom on this. Because they tell us 1 velocity and they tell us 1 acceleration, and being 1 degree of freedom, we can find any velocity or acceleration you want, and we do not need a free body diagram. Okay, so in this particular case, I plan to use special points because I can't really think of a vector loop that will bring in all these points. To start the problem, you have to ask yourself, how many rotating bodies are there? There's 2 rotating bodies. AB can rotate because as this little blue gear rolls on the rack, the point B is going to be moving around in a circle. So this AB link is probably going to rotate. And also this blue gear can rotate. So there's 2 rotating bodies, AB and the gear. On body AB, there are 2 special points, A and B. So I would expect 1 special point equation from that body. There happens to be 3 special points on the gear. That's this point right here that I labeled in. It wasn't given by the author, but clearly that point right there is on the blue gear, and it touches the rack and the blue gear. Point O is special because you know something about it. It's moving. It's a fixed distance between here and the wall, and so that distance right there never changes. So therefore, you know that this velocity and acceleration is vertical, right? So you know something about it. That's what makes O special. B is special because it's touching AB and it's touching the gear. So that's what that makes that one special. So because there are 3 special points on that gear, or on that body, we're expecting to write 3 minus 1, 2 special point equations. Okay. I like to start with the velocity equations. First, let's take the first body, body AB. I'm going to choose, there's nothing to choose, it's either A or B. You start with A or you start with B, take your pick. I always like to put the points I know most about over on the right hand side. It's just kind of a habit, but you can do it any way you want. So anyway, I write velocity B equals velocity of A plus omega, the angular velocity of the body they share. Obviously that's body AB, and the R goes from A to B. Right? The V rels are all 0 because A and B never get further or closer together as it moves. It's not rubber, right? So that's that equation. I'm going to plug some things in that I know. So the velocity of B, I don't really know much about it. I do know the velocity of A. I know that it is going down with V, so it's 1.7. So the magnitude is 1.7, and the direction is minus J. The negative goes with the J because it's going down, 1.7. I don't know anything about the omega, so I'm going to assume it's counterclockwise. So I put it in as a positive K direction, and the number, I don't know, WAB. Crossed, this is the vector from A to B, so I'm going to go to the right a distance of, I think I got that, no, sine of 60, yep, so I'm going to go to the right, 0.5 sine of 60, and that's a positive I, and then I'm going to go a distance of 0.5 cosine 60, and I'm going to go down. So the negative goes with the j because I'm going down. So that's the r vector. Okay, then I'm just going to do the cross product. So I'm just going to simplify it a little bit. Do the cross product. So k cross I gives me a j. So that's this term here, 0.5 sine 60 omega AB. K cross I is j, positive. And then I'm going to end up with a 0.5 cosine 60 omega AB. And then I have a k cross j. A k cross j is minus I, so minus with this minus gives me a positive. So I've got the equations here. And then I do the equations that I'm expecting for the gear. All right, so I'm going to do those in red. Velocity of B. You now have 3 points, so what do you pick? Do you want B and P, O and B, O and P? You got a number of things to pick, but you can only pick 2 of them. I chose B and P. The reason I did that was because in the black equation I had B equals. So what I'm thinking is it'll be easier to solve if I put B on the left-hand side in a red equation, because then I can eliminate the B fairly quickly. And then I like the P over there because I know a lot about P because he is in temporary contact, no slip, with a stationary object. So because I know more about P than I do about O, I'm going to use B and P to start with. But you can start with any two. The numbers will be different, but when you finally get the answers will be exactly the same as what I get, unless you made an algebra mistake. Okay, so the velocity of B equals the velocity of P plus omega that they share. Well, this one is the gear, so it's the omega of the gear. I'm assuming that it's going to go counterclockwise, so I put it in as a positive K, and then I cross it with an R that goes from P to B. So from P to B is left, that's why it's a negative I, and the distance is 50 millimeters, so 0.05. And then there's no rel terms because B and P are on the body together. They don't get further or closer together, so there's no rel terms. Okay, so then I'm just going to simplify it a little bit. So B equals the velocity of P. Well, P is in temporary contact, no slip, with the rack. So the point P and the rack have the same velocities in all directions. Well, the rack is stationary, they said, so that's got 0. That's why the velocity of P is equal to 0. And then I'm going to do the cross product here, so I pull out all the numbers, 0.05, omega gear. K cross I is a positive J, so the negative here comes over to there, and I get a positive J there. Okay. So we'll do the next equation. All right, so I'm going to choose O and take your pick. Do you want to use B or P? Well, I like to use P. Why? Because I know more about P than what I know about B. So that's why I chose O and P. But you could do it with O and B. So anyway, velocity of O equals velocity of P plus the omega that they share, that's the gear. And I'm assuming, just like before, I'm assuming it is counterclockwise. So whatever I did on the first red equation, you better do the same thing in the second red equation. Okay, so it's a positive K omega gear. This time R is going to go from P to O, and from P to O is 200 millimeters, so that's a 0.2, and it's left. That's why it's a negative I, because it's left. And then again, there's no rel terms on this term either. Okay, so we'll simplify it a little bit. VO equals 0. Again, it's temporary contact, no slip, so they have the same velocity as the rack. The rack is not moving, so it's equal to 0. Do the cross product, so you have a negative 0.2 times omega gear, and you're left with K cross I. K cross I is positive J, so that's why you get this negative, gives you this negative here, right? Okay, so then in blue I'm going to circle the unknowns, and VB is circled, and there's, as far as I know, there could be 2 pieces. There could be an X and a Y, so that's why the little 2 right here. So there could be 2 unknowns there. What do you know about O? Well, I'm pretending to be a dummy. Oh, I don't know anything about it. Well, yeah, you do. You know it's going down. But anyway, I say, oh no, there's two unknowns there, okay? There's also one unknown here for omega gear, and there's one unknown, nope, that's it. So there's 2, 4, 5, yeah, there is, okay, there he is right there, omega AB. I don't know omega AB. He's circled in blue as well. So that's 2, 4, 5, 6 unknowns. So I have 6 unknowns right here. How many equations? Well, this vector equation right here is a vector equation, so the i's on the left equal the i's on the right, the j's on the left equal j's on the right, so you get 2 equations there. This vector equation right here gives you I equal I, j equal j, so there's another 2. And then this vector equation right here gives you I equal I, j equal j, that gives you another 2, so you've got 2, 4, 6 equations. So you have 6 equations, 6 unknowns, bam, you can solve this. Okay, so how am I going to solve it? Well, first thing I'm going to do is I'm going to set the black equation here, because I really don't care what B is doing. So I'm going to take the right hand side of the first of the black equation, this one here. I'm going to take the right hand side of that and I'm going to copy it down here, because that's VB. And then this equation right here, this one, is also telling you what VB is. So they have to be equal. So I'm going to take the right-hand side of it. Boom, right there. So the right-hand side there equals the right-hand side there. And I've eliminated VB. So instead of solving 6, I now only have 4, really. Okay, so now you pull off all of the i's and the j's. So over here on the, let's see, I'm pulling off the i's. So there's an I term right here. 0.5 cosine omega b. And there are no I terms over here, so it's equal to 0. So omega AB is equal to 0. Bam. Maybe you knew that, maybe you didn't, but the math will tell you that, okay? And then you take the j's on the left-hand side, negative 1.7. And then, because omega AB is equal to 0, 0.5 sine 60 times omega is 0. And on the right-hand side, you end up with a negative 5.05 omega gear. So that's j equals j. And so here you can solve for omega of the gear. So omega of the gear is a positive 1.7 over 0.05. The positive says, yep, I was right when I guessed the direction. I always guess it's in the positive k direction, so therefore I'm right. It is. It's actually counterclockwise. And so now that you know omega gear, you can go back in and get this guy right here for the VO and put it in right here. VO equals negative 0.2 times omega gear. You just take 0.2 times 1.7 over da-da-da, and you get a negative number, right? The negative says, no, you were wrong when you thought you knew what it did. You thought it was going up, you're wrong. It's going down. So it's in the negative j. So it's going down 0.34 over 0.05. Okay, and you probably knew it was going down, but it confirms that it was. Okay, so now to do the acceleration, we're going to mimic the velocity solution. Okay, so if you look back up here, what did you do for the velocity? You did a between B and A. So I'm going to go between B and A. Acceleration of B equals acceleration in A plus alpha. Instead of omega, it's alpha. I don't know what direction it is, so I'm going to put it in as a positive K, so I'm assuming it's going counterclockwise. Cross R, if you notice, the R is exactly the same R as it was before. Right here, 0.5 sine of 60, negative cosine of 60, okay? And then we're just going to simplify a little bit, so the acceleration of B equals acceleration of A. You plug that in, that was given. It's 2.2 and it's down, that's why it's a negative J. If you do the cross product, you end up with 0.5 sine of 60 alpha, and then k cross I is a positive j, so it's positive j. And then for this one, it's a negative, so first thing I do is I write negative here, and then it's 0.5 cosine of 60 alpha AB, so I just pull the numbers out. Then I do a k cross j, gets you a negative, so a negative with a negative makes this a positive here, positive I. So I did the cross products here in the black. The next thing that I did was write a velocity, we're looking at the red ones now, a velocity between B and P, so I'm going to do acceleration between B and P. So the acceleration of B equals acceleration of P, alpha cross R, again, it's exactly the same R as it was before. Omega of the gear times R. There's no rel stuff, just like before, because the 2 points never get closer or further apart. The last equation that I wrote up here was a velocity between O and P. That's this one here, between O and P. So I write an acceleration between O and P. Acceleration O and P, alpha cross R. Again, it's exactly the same R, minus omega squared R. Right? Now all I'm going to do is I'm going to simplify, like I did before. For the velocity terms, I took the right-hand side of the black equation. So I took this right-hand side and set it equal to the right-hand side of the first red equation. So that's what I'm going to do here. I'm going to do it in blue. So I have the acceleration of A is negative 2.2j. Plus 0.5 sine 60. So I'm just copying the right-hand side down. Set it equal to the right-hand side of this one. Now let's take a look at what P is. Just like before, P is in temporary contact, no slip with the rack. So what the table tells you is the temporary contact, no slip, the accelerations in the plane direction, that's the vertical, are the same. That means that the acceleration of P vertically is 0. It tells you that they're different in the normal direction. In the horizontal, they're different. So that's what I'm plugging in down here. So the right-hand side, the acceleration of P is vertically 0, but horizontally in the I direction, as far as I know, there could be a piece, and so I assume it's going to be to the right. And then all I'm doing is I do the cross product like I did before. So alpha k, this alpha of the gear is alpha k. I'm assuming it's counterclockwise, like I always do. And then I do the cross product, and I end up with this term right here. And then this omega squared term becomes this one. Okay. So now what I'm going to do is I'm going to extract the equation. So I pull off the j's first. So here's a j piece. So minus 2.2. Here's another j. And then on the right-hand side, there's a j term right here. Right there. So that's one equation. Oh, incidentally, what I did here is I counted the number of unknowns. So here, I have an acceleration of b, which is unknown. It's going to give me 2 unknowns. I don't know anything about it. The angular acceleration of AB gives me another unknown, so that's 3. The acceleration of P, I know that from the table, I don't know the horizontal one, so that's another unknown, that's 4. Alpha of the gear gives me 5, and then the acceleration of O, if you look at it, the acceleration of O has to be vertical. It cannot be horizontal. So there's only one unknown there. So there's 2 unknowns here, 3, 4, 5, 6 unknowns. And of the equations, I have 2 from here, 2 from here, and 2 from here. So I have 6 equations, 6 unknowns. That's why I decided to try and solve it. Okay. So let's go back to what we were doing. If you pull off the I components of this blue equation, you have the I component right there, which is, this is an I component. Then you pull off the right-hand side I components. You got an I here, and you have an I here. All right, so in these two equations, you have three unknowns, so you can't solve anything yet. So we're going to bring this red equation down. So the acceleration of O, I know it's vertical. I'm assuming it's going up, obviously. And, you know, I'm wrong, it's going to go down. But anyway, I put everything in as positive. So I say it's a number, and it's in the positive J direction. But I do know it's 0 because it's a constant distance from the rack. Acceleration of P is, I assume, like I did before, like up here, that the acceleration of P is to the right. And then I just plug in the cross product, the alpha gear cross K cross I is a J, and then I bring down this omega squared term right here, and then extracting the equation. So on the left hand side, the i's, I have no I. And then on the right-hand side, I have an APX, and I have a 0.2 omega squared. And then on the left-hand side, the J's, I have an AOY, and on the J, I have a 0.2 alpha of the gear. Okay, so what you do is you solve the equations here. That's 1. Here's the second equation. It's 2. Here's a third equation, right there. And you really don't need this one, unless you really want A or Y. So you have the three equations, and the number of unknowns is, in this equation, you have alpha gear, and you have alpha AB. Here you have APX, and here, let's see, and that's it. So you have 1, 2, 3 unknowns, and you have 1, 2, 3 equations. So you can solve for these guys, which I'll leave for you to do. Okay. And then if you really wanted to, you solve for the acceleration of O. And what you'll find is that this is going to be a negative number, meaning that it's going to go down. Okay, that's it.